Cool.
Have any secret?
The top secret of Pappachuck.
How I hide this thing on the top?
I think you can minimize it.
Whatever. So let's start from basics, right? So what happens when you run this command, right? This is Python script you already figure out
Mhm.
that comes from this thing. It's this Python script here. Doesn't matter if it's Linux or Ubuntu. This Python script is basically wrapping up this software project, which has many things only Python, has also a C++, C, and a few other languages. Is wrapping up through your Python compiler on your computer and is running the app, or in this case, Isaac Sim. So what we did is to install, like with the pip install, we're installing with this compiler, we're installing OIGE. The Conda, I don't know how that works yet. Like I haven't done that successfully work on Windows and Linux equally. So what's doing here is that I'm calling the compiler that has OIG installed on it, and I'm calling scripts, and scripts here. Random policy obviously is not doing anything, but like let's see, go to train. Oh, this little window. Oh, there you go, minimize. Okay, so this is doing many things. So they have a choice of using Hydra. Hydra is like is a Python manager. Let me. So Hydra Python framework is not the delegate. There is like a Hydra which is the render delegate, which is also used in another part. So how I share with you this? Yeah, I just send directly here. So it's important to remember people that they're using Hydra. This is Hydra.
Cool.
And now I
And that's
cannot
like a
minimize them.
configuration tool to track
Yes.
where things are being piped in and piped out, like hyperparameters and stuff, right?
Yes, that's where you pass a YAML file. That my personal opinion is to change this to cloud native format, and we have to refactor all these things later. But that's what Hydra is doing, and this Omega G config gonna transform the Hydra YAML file into a Python dictionary. So this is your beginning class. They're gonna be instantiated to run. So you see here is if name main parse Hydra config. So what it's doing is that when you launch this thing here, you're gonna parse the Hydra into Python dictionary, and then you're gonna instantiate utils, task utils. This is where the RL games train whatever, you're gonna instantiate a bunch of classes. One of them is utils, and this is where you're gonna put your robot. What is the task or the Python script that's gonna go here on tasks? You're gonna have to instantiate it here
Mhm.
for each robot, and then you have the dictionary of the tasks, and you can see that the task B1 is this here, is this dictionary. So Hydra is picking up this value and then gonna instantiate into a Python dictionary. They're gonna be used here to find out like which task to run. And then you see here is search is doing a map. I'm gonna mesh this with this. I'm gonna grab the class and we'll instantiate the class. And we run two things, synconfig and the task. Synconfig is a little bit more complex. I prefer dive to that later. So then you go to task and B1 terrain doesn't work, but B1 does work. So basically you're gonna instantiate the task with a base task, RL task, which already has many of the things you're gonna need to do the training. And then other things are things you're gonna get from the core, which are gonna allow you to get the prims. I don't know if you know, but USD has the prims, that has the the things attached to each, where the rigid bodies, meshes, collisions, and the joints are all in prims. This is a hierarchy of prims. So you have to get the paths for the prims in order to get where the joints are, how fast they're moving, and things like that. And then here we instantiate again from the Python dictionary. We're gonna instantiate the values we need to perform the training, which is quite a lot. And this is like where, you know, QP comes in. It's just basically quadratic programming. You define your strategy, and then you just instantiate it. And I just prefer, since the quadrupeds are all the same, all have 12 degrees of freedom. Even if they had one less degree of freedom, it would be just easier to modify the code for animal, which I use. It's just easier to recycle the code. So
So
then
do you like
this is
create a new
important.
instance of animal and modify it right there on line 100?
I think I might bring it to like some of our demonstrations.
Oh no, no, like I just use the code they use to train animal
Okay.
and just change the things they need to train the other robots.
Okay.
The it's easier because it's already everything set up. It's just easier to refactor that. You're gonna work the same way. So this method, this is what's gonna get the environment created, like the everything and the robot into the environment. And then we split this into other methods for simplicity of the code. So in this case, get animal is right here. So get animal gonna get the USD file for your robot. On this case, I place it here. You can change this also to work with Hydra. You can create like instead the hard link, you can change this. So again, you're gonna use syncconfig, which we instantiated on the task we choose. And you're gonna just prepare the robot and add it to the environment as like with the paths, like envs, like you're gonna create like env0, env1, env2, and then they do not have collision between each other, and they don't have many things. It's basically each robot is an individual environment which has its own collision and is doing its own calculation. And also it's instanceable, which is important. So like instanceable, as I'm gonna open, let me see, I think this works. Nope. Okay. Ah, I'm on the wrong one. There you go. There you go, it should run now. I'm gonna show you what the env means. I made a workaround on the terrain, which I'm also gonna show, but that's actually a big issue that needs to be fixed, and I don't think the NVIDIA people themselves, they're trying to fix the issue too. Like I think like it's a really bad issue.
Is that where like the mesh isn't collidable or something on the terrain? What's the
Because they're
issue?
using pixel physics, and that does not match the kit physics and physics, and like there's a mess going on there. Like you just any robot you import other than animal does not collide. And some robots they spawn inside the collider, and it's just messy. Right, so just random policies so you can actually pause and fly around. Okay, so here import the B1. See, in this case I put a ground plane on the other plane, but what happens at kit, somehow when I create a ground plane with kit, doesn't matter where this ground plane is, the standard ground plane starts to collide the robot for some reason, which it shouldn't. So that's messy. Okay, so on the word you can see you have the default plane which should work. This is creates mesh. a mesh, which is the terrain, which I'm gonna show later. And these are the robots. You see environments. Each robot is an independent environment, which is pretty cool. And as you can see, you match the names here. So it's just looking for the paths, like HAA joint is on a base, right? So then I'm gonna go here, base, have the joint. Of course, it's not going to show here, but these are the joints is here.
Does I see that it says like fabric GPU or CPU, I mean, does that mean that these are represented only on the CPU, or does the GPU also render these?
You can change this. This is not important.
Okay.
This is configurable. I'm doing this for sake of simplicity, and also you can do multi-threaded, which is much more harder. And you can use Insight and other tools to enhance the GPU utilization and memory and optimize those things. But you don't wanna, actually, you shouldn't do that before you actually have something that works. And then when something works, then you think about optimizing.
Right.
All right, so this is what getting animal doing. It's just getting animal, getting the joints, getting everything set up. Views is doing something also really cool. I go here, robots. This is where you get the robot to be set up. Let's say B1. I hate this thing. Okay, so as you can see, is instantiated from the class robots, which already has a lot of things to get the joints into the RL games. And in this case, here you can see that if you don't specify a path, USD path, like we did specify a path. If that is not there, you try to get the animal. You can change this to just make this work also. It's not important. This is the join names. This is very important. This has to match this. So it's not here, it's on the views, but it's gonna look like inside base, and then you're gonna look for the dictionary. This case it's not as the list, but you're gonna look for these names. I has to match here. And hip has this LF HFE. And you got the idea. View's gonna get that and create a view, which is what literally gives you the access to like what's happening to the joints, to the drive, to the contacts, which is right here. B1 view. It's just a tiny piece of code. See, is searching for tie, and then you're gonna look for this. So the tie is this new one here. So you're just gonna look for tie and base, and just gonna get the X form properties that like where this prim, the X form of the prim and its properties. And this is what's gonna be used to calculate the rewards. Like if this base moves too fast or too far, you just create a state where it's a failure and a state where it's a reward using what you get from views. And this like gonna get the knee, as we call here. Knees is this thing here. And then if knee is below certain threshold, it determines a failure or success. And then he also has the base. So this is like where is what allow you to set up the reward for success or failure. Okay, so now this is the robot thing. So now we go to the YAML itself. So this is actually very important. Here, numeral environments, right? If I put 4096 here, I'm gonna have 4096 robots. If I put 4, has 4. But this has to match the mini batch on the PPO algorithm. They have to be divisible. Okay, so I'll come to that soon. And then this is quite obvious. The spacing between them, like the action is gonna take, positioning, like if they start rotated, if they start up, down, if they start walking. And then there's other things that were added on the code you train, like your random velocity ranges. Like it's just trying to make the controller to figure out how to walk at 2 meters per second, -2, like backwards. Or you can also train it to just rotate in place or a mix. And then you set up like the starting joints, like when they reset, like this is how they're gonna start. Some rewarding, the sim, gravity, like the physics stuff. This is the complicated stuff that I don't know. And yeah, you can see I should left animal here, but yeah, this is not that important. But yeah, just overrides the things on the robot itself. Then you go to train. P1, PPO. Okay, this is proximal policy optimization. As you can see, this is the mini batch size. So mini batch size 32,768. So as you can see, I believe 32,768 divided by 4,096. See, it's divisible. It has to be divisible. So the amount of robots has to divide this number, and it cannot be a fraction. And yeah, so this is tricky. This took me some time to figure out, but yeah. And this is the other things you set up for training to happen. Like, it's actually very important, but I will do this later after it runs. So this is how you're gonna save the run. The checkpoint's gonna be saved in this, and there's somewhere here where it saves here after 250. So like and scores. You have to set up these things here under the epochs. Depending on what you do. Where should I go now? Okay, so yeah, this is the train, the config they're gonna be getting. Config them with just like a factory to build this. Demos, I didn't code this one yet. Like this needs fixing, but this is what this is doing is that like you're gonna create a camera and then set the keyboard event. So like when you click on the robot, you're gonna create a camera on the robot and you're gonna be able to control it like with whatever keys you set here. You could change this to stream to RAWs or outside the computer or to joystick. You can actually make it like a video game and you control the robot. This is something I'm gonna play later. It's not that important right now. This is just a base thing. The RL games create the environment itself. Just I would mess with this right now. It's complicated. I have to go to now here. So this RL task is very important. This is where lots of the magic happen. So when you create a robot, let me just fix this. Go here. You can see that it's instantiated from RL task. Okay. So RL task where the magic comes from. And then I get that from base task, which is a core thing. Some things from base task. But this is what will create everything. So this is how we're gonna be creating the scene. They're gonna be creating the scene of the robot, adding collision filters, which if you can, let me go here. Collisions, you can see there's a global group with filters. So it filters these things and then just add colliders. And then group 0, you see, because they filter everything, it means that they cannot hit each other, but they can only hit the ground. This is where that you set up that if you do that and then you have a bunch of robots and then they can collide with each other, on the terrains, they start on the same spot, so that will cause an explosion of robots. It's kind of cool to watch. This is my workaround. I added a ground plane, which is this white stuff, and it worked for some reason. Doesn't matter, as long as it's below or the same height as the original one, it works. It doesn't matter really, and somehow it works. I don't know why. What else? Yeah, this is what creating the prims, like the env 0, 1, 2, 3, like the camera, the properties and stuff. Like you're gonna need like, yeah, but this is the trick, and this is using this thing here called utils, terrain utils, and this is what's broken. This creates the terrain, the cool terrain, which you're gonna pause. B1 terrain, this creates this cool terrain. I think you're gonna run. So far, any questions?
So have you found that there was a difference between running like on Windows versus Linux, or is it pretty standard across the two of them?
There are some differences. Okay. Some things run better on Linux. Apparently, it seems that Linux is much better to optimize. You have access to Jupyter Notebook on Linux. Works better with ROS. You can actually like on Linux is better for you to pass things from the robot to outside, like camera stuff, because it integrates better on the lower level.
Mm-hmm.
See, it just falls. Yay, look there. But like it makes this cool terrain. Somehow it collides with some part of the terrain and not with others from some magical reason. And what's worse is that you see there's invisible pole it
Like
collides with.
floating above it.
Yeah. But this code is making this terrain, which in my opinion is the most important thing, because it makes all sorts of things you wanna train the robot on.
Mm-hmm.
So it's that's what I'm trying to make it work. I really need just to work to actually make it walk.
Right.
Yeah.
Huh. It's interesting because it's kind of floating above the area, much like the Go One was when it's how it
Yes.
floats. I wonder if they're like the way the Go One and the B1 like USD file was created, if there's something with the colliders generated it. Do you know if there's other people that have created USDs for those robots?
What USD for the robots?
Yeah.
We just use the URDF importer and we import it. You're gonna see how weird it is. Now add physics rigid body colliders preset. Boom, see, it doesn't work. It's even
Does the
worse.
physics so
Remember, right? What I told about config, the task, scripts, the robots, where the robots are. The problem with the terrain utils and this here. So on base on RL task is what actually is creating the terrain and stuff, is where everything here is built on top of this. So there's something wrong with terrain utils that I don't know, and then I was trying to solve it today, and then I was making an extension. So like the mesh, somehow it doesn't work, and then it doesn't collide, and weird enough, not all robots work. Some work, some doesn't. So I don't know why either.
that's
One robot
interesting.
like it didn't work, and then I deleted something and it started working. And then I tried deleting stuff and it didn't work.
Hmm.
See, look how weird it is. It clearly is trying to move, but it's
Hmm.
not. And then if you do this a bunch of times, eventually they explode.
Oh, when I do it, it's the first time the system will actually just crash. It won't
Oh,
even.
no. If you do stop, it crashes. If you do just pause and pause, it works.
Oh.
But if you do here, show by type, physics, colliders, all.
Oh, interesting. That could be a problem. The
But you
collider's
see,
not in line with their
no, that's
mesh.
not the problem. That's how they start. They start like this. This is not a big deal.
Okay.
This is normal. But the problem is they're flying. They're stuck somewhere, invisible. Yeah, and it does not use physics. It's not using physics. It's not using the colliders. STF doesn't have any of that.
Huh.
So it's using Pixar physics. That's on the USD physics, plus some custom stuff. It's not using physics entirely.
Hmm.
That's the biggest problem, and I can show you where. Terrain, choose, I think it's right here. I see physics collision API. This is Pixar. See, is USD physics. It's not
Hmm.
NVIDIA physics. Then when I do this, key commands, just playing around. Where is the thing? Ah, it's worse now. Oh yeah, here. Okay, so I was trying to jerry, right? So you see what I did here. I tried to put a rigid body on the terrain. At some point to work, but it was funny enough, everything fell. Like the terrain, the robots, it was funny. And the cool thing is the camera followed the terrain falling, so I was like everything falling together. And the robots trying to move was kind of that worked incredible enough. And then when I made it fix, you saw the problem. The cube had an offset. It happened there. The robot hit something, had an offset between the ground and the thing, and then it didn't. And then when I deleted this thing and then put just to add a plane on the regular one, some robots work on this plane, some robots do like this. Like another one I have, I really like this one. Spot micro. Then I'm really bugging out the whole day. Spot micro AI, right? Yeah, I wrote it wrong. Spot micro AI. I think I have the code right place from this project. It's called Spot micro. Super cool project. I
Oh yeah, I've heard of that. That's awesome.
Oh yeah, this project is awesome. You have my repo. My repo have everything.
Hmm.
This repo here. Oh yeah, so navigate you to the repo. Very important, okay, so you don't mess up. This is where the robots are. And then I have the URDF descriptions. Not all of them work. Okay. I don't know how many I have. Yeah, I have a bunch. Okay. They not necessarily they're gonna import like a straight path. And then you have the OpenUSC assets, which I already converted. And then you have the things you saw, right? The meshes, the USD stuff.
So you just went through and on your own created each robot's USD.
Yeah, and then I put documentation, link the links, and a lot of stuff. I need to find people to help me. Okay, this is where the robots are.
Hmm.
This is where I duct tape stuff. As you can clearly see, it's duct taping. What's the duct taping? Okay. I saw one already exploded into oblivion. Okay, so
Nice.
this is where I put stuff like where I start converting. See, like I pick the code from animal and then I start modifying stuff until I felt confident it would work, and then I put on the main one. These there's OIG, orbit. it's worse than this. It's way harder. Don't do orbit, like, unless you want to spend your entire month figuring out how this works. It's
It says
horrible.
because it was like Isaac Gym, and then it was like Orbit, and then it turned in back to Isaac Sim or something like that.
No, it was Gym. There was, I think, based on PyBullet or something like that. They move around in many different types of engines, and then they create Sim, and then they adapted Gym to work on Sim, and then they create this wrapper thing with the Python script where they get Gym environments into Isaac Sim, and then they made Orbit to do something else. The Orbit was really good at is really good with like I think it's RMP and other algorithms to path planning, robotic arms, and a bunch of other stuff. They made Orbit to do that. And Orbit is built different than Gym, so it does not even use the Gym. Orbit is for inverse kinematics, a bunch of stuff. And then they adapt stuff from the RL games into Orbit. And then they realized that was messy. And then they realized OIG was easier, and then they started to convert OIG to become Isaac C native. And then these things broke because they updated the basic stuff like physics and everything, and then everything broke. And then they're working on fixing that, and then Orbit is like, I don't know what's happening with Orbit, like they're trying something new.
Oh boy.
That's the story. Okay, so you see the spot micro, as you can clearly see, also gets stuck. If you do a bunch of them, for some reason it doesn't work, right? But if you actually, funny enough, if you, where not here, so if you actually go here and go on the tasks. Oh yeah, I forgot to show you this. Spot micro AI. So there's a variable here called tensor. So you have to modify two variables to start where it spawns, right? You see here, animal translation. This is gonna set where it starts, X, Y, Z, right? So if we change this to 0.4, and then you go back here to task, all the way down here, and then you go here, 0.4 meters, right? And now you should spawn 40 centimeters above ground. Oh man, there's so much stuff to set up. Of course, you have to set up the velocities to match a realistic velocity, otherwise I think right now this is more like art than science, because you have to manually tweak it, and you never know what you're gonna get. It's like you go changing the policies and the stuff, velocities and learning rates, and you go literally, you have a general idea what you have to change, and then you have to manually change it until it kind of works, and that takes a massive amount of time, and then you transfer to the real robot.
Have you been able to successfully train a like a V1 or something like that?
I train the animal successfully, and I train the spot. I have a spot. I don't know if you saw my model. The spot works very well.
Right.
See, it doesn't really do anything. It just fucking, it didn't even go up. Man, my life gonna be challenging.
So you have to change it on line 99 as well as the YAML files?
Yes, but there's something worse happening here. I don't know if you've seen, but I put 0.4, but it did not start at 0.4. As you can see, if I freeze, go to environment 1, spot micro. Yeah, it started at 0.4.
What if you did like 2.4 or something? See if it actually is.
Let's do something crazy, right? Let's put like a whole meter. Yeah, so this is important. And then if you want to figure out the terrain is not there. Terrain is here. Is on the function get whatever, get animal in this case, get the robot.
Mhm.
Just set the orientation. I'm gonna rotate it. This is a quaternion. So be aware.
Mhm.
And this is XYZ. And it has to match the YAML. That there is a reason why it has to match. I just don't know exactly. So right now it's just like literally playing, like you just like a child just messing until it works.
It's the epitome of getting this stuff to work.
Yeah, so you will realize that it's the thing to make it work is about how fast you can iterate through failures.
Yep.
That's why I made the AWS container, because like on a okay, I didn't figure out that part yet because we'd have to route it. But let's see, if you have 5 virtual machines on the cloud, right? You can have 5 of these things running at the same time, so then you can fail faster.
Mm.
That's the big brain strategy. So you can, instead of having to wait like 4 minutes to load every single time, you now can run one and run another one and run another one and just go failing faster until you figure out.
That's awesome.
Is so you change to 1 meter and now it works for some reason. It's worse. Like you see how crazy it is. No, it works, but like why? Why 1 meter works, but why like 40 centimeters doesn't work?
I wonder why. I guess is it terminating because they're not
You remember the
landing?
thing I showed you on the RL task?
Mm-hmm.
It's not here. I think it's on views, that when the body or the news goes through a threshold, it triggers a reset function that recycles the individual robot. So what's going under the hood is the Python is running, because now multi-threaded, is in sequence looking for every single robot and advance one tick or step of the simulation. So the simulation, I don't know how many frames is set, but let's say it goes this frame, you're gonna look for everything, the world, the robot, the colliders, do all the calculations here, and then you're gonna then move to the next one and redo it again on a single thread, the single thread. When you do multi-thread, the numbers of environments is split between threads. And then you have to do some strategy to optimize that, but like it's way more complex. I think I have an example. I wouldn't do that. Like honestly, if that's too hard.
But theoretically, it would be faster to train everything, right?
This is where you put your PPO. See? Oh yeah,
Oh, yeah.
no, it can be slower too if you don't know what you're doing. You're gonna send something to the wrong place and it will take too long for the memory, and then you'll be slower.
Oh, yeah.
It's right here. See, it's like the RLG trainer is what is launching the algorithm. So as you can see here, the PPO trainer is threading, and then you're doing and then you're gonna run this stuff. I'm gonna set up everything. It's way more complicated. I don't even want to go into this. Right? But you see the trainer, check is running, and then they create a task. I go to there's a class, they initialize task right here on task util, initialize the task, and then it pass the Python dictionary to the synconfig and to the task.
Mhm.
On the task, gonna launch. But the thing is, because multi-threaded, it does something else. Oh, this is cool. This was a realistic goal I was trying to do tonight, like get weights and biases, so you can actually see the training.
Oh, that's cool.
Dude, this is
What does MT stand for?
multi-thread.
Oh, okay.
So
Okay.
of course need to make it work, right? Like, and then you figure out how to multi-thread it, which it's very hard. And then, because think about it, Ital multi-thread, it takes 3 hours to train on the crazy terrain I show you, and it works fantastic. So probably for your research, it can train also in 3 hours or less to do what you want. Like, so like you shouldn't worry about multi-threading. If you multi-thread, you could make it probably doing it in an hour or less. Like, it could be something ridiculous. Would be cool to show off to people, like say, oh, I trained the entire thing in like 10 minutes. Just so you show like.
Right.
But there's no much point in doing that.
Right. Except for the failing quickly part.
You see, but no, that doesn't work that way. Okay, so you cannot optimize these things if you don't know what you optimize, and then if you don't know what you fail, you can't optimize.
Yeah, that's true.
Because you don't have the thing, you don't know what's failing, right? So you kind of have to build the thing first to figure out how to optimize it. So optimization happens only after you have everything working, and you want to make it an algorithm that is really good at training for certain narrow tasks. So like I don't know, maybe you know you wanna do like the soccer, the Robo Cup, right? If you wanna compete on Robo Cup. So let's say you figure out now an algorithm that makes the robots do the ball thing. So when you figure out that, then you optimize that, then that's when you use optimization, because then you're gonna have to just work on the tiny little tweaks to actually make them like compete on the. You just tweak hyperparameters and tiny things. You're not actually messing with the thing. I don't know, like what else do I need to show you?
Well, I think I have a lot to go on right now. I kind of want to just try some things, see if I can
just go
play
on,
around.
just go on the thing, just try and
yeah, see if I can, I don't know, learn about how to set up a robot and configure it, and then
I did around 90% of the work, right?
I know. I just gotta change a few things, and then bam, it'll be ready to go. And then the other challenge is once we have a model that, let's say, works in simulation, I got to deploy it on the actual robot, and that'll be an adventure. Trying to make
No,
sure
that's
that it
actually
doesn't.
so easy. Like once you have the, so that's something really cool I didn't show you, but this model you're gonna put on something we call inference server, right?
Okay.
So your robot, I think, is compatible, like in needs about a kilohertz, right? Isn't that how fast your?
Something like that, probably. I'm not familiar.
So you make inference server using Triton, and it runs on a container that you can run on the Jetson, and then it's just fast enough. And then the trick is on your robot. Oh no, it's you make your controller. You make a little NPC that can switch in between the busier gate. What's the normal gate they do?
Like a walking gate or
Yeah, you have
running
the
gate.
handcraft gate, and then you have your AI gate. Right? Your trick is to tune the NPCs so it catches when you're gonna fail, so it goes in between them.
Okay.
So then, like when your AI thing is working, like you're doing the commands, the inference service is running and sending the velocity to the joints, everything's fine. Is using that. But like when your predictive controller sees it's off, because it's running like the inverse kinematics, when you see it's off the threshold you set, it goes back to the normal gate. So that does not work if it's running. Okay, so you have to be careful, because the handcraft, if you make the AI run, you're gonna create momentum on the robot, and then if you switch to the normal gate, it's just gonna,
Right. Oh
Yeah,
man.
and also if you switch and there's a difference too great that then the motor can accomplish, that's when you burn the motor.
Oh yeah,
Yeah, be
that makes sense.
careful.
Do you have
Another
a
trick we have,
result, like a repository of someone doing this?
no, I have to search that, but the feet of the robot has a sensor. Be careful that you sometimes the sensor sends a false signal to the to the RL inference.
Mm-hmm.
So then the feet touch the ground, but the algorithm does not understand. It receives a signal that does not seem to touch the ground. And
Mm-hmm.
then you're gonna try to move the feet until it touches the ground, and then that's when it does those weird stuff.
Interesting.
Yeah. Also, when you hang it and it's trying to find the ground, it's weird. You can see that if you put the walking after you train the robot to walk, if you hang it up, it's funny. It tries to find the ground.
Mm-hmm. If it can hit the ground and sense the impact of the little.
Yeah, but the
try
detail
that.
here, these robots don't have self-collision, right? So it does not. This algorithm does not work with self-collision. It crashes the whole sim.
Oh.
So because it doesn't have self-collisions, the only thing that limits how much you can move, it's your joint configuration, which you can't really configure everything. So your algorithm you train here will try to make movements that will clip through its body. Okay,
That's not good.
so that's why you have to be very careful when you train and you transfer the real robot, that your real robot is not going to be in any situation that you would do movements that would work on the sim but doesn't work on the real world.
That's scary.
Otherwise, you're gonna move, hit its own body, and try to keep moving.
Mm-hmm.
Yeah, and then you're gonna lose money too, like because it usually breaks.
Yeah. That's not
Okay,
good.
very important to remember that. Don't forget that. Like self collision crashes the sim.
If we wanted to make it self collision a thing, you don't know of a way we could enable it, or is it just like just everything just dies?
Here I'm gonna find. So see, go inv to a robot here, right? So on physics has self collision on the articulation roots, but the problem is that like when we enable this, break something here on the views that's actually trying to get the collisions and stuff to train the algorithm, and then just crashes the whole thing.
Mm.
So to enable that, you will have to rewrite the entire code base and also rewrite some stuff on Isaac itself. Too much work. See,
Yikes.
like, yeah, don't just make a joint that doesn't collide. Like I don't know, like just and that's something. I don't know if you know how to make joints. Also, there's other issues. Oh man, never stops, right? Where's the joints? Okay, so the joints. I'm gonna show you how the joints work. The joints, when you create a joint, it has a drive. You have to rewrite the drive to work with the RL. Otherwise, it won't drive. Dude, this is too hard. Like I didn't realize it's actually hard.
There's like a million things that have to go right for it to work.
Yeah, I'm sorry. I was thinking because when I wrote my documentation, I started writing this thing, and then it became here, right? You see how I start writing, and then 1 page, 2 page, and then like it become 10 pages with this, and then one doc became 20 docs because I have more docs.
Oh my goodness. That is just insane.
I'm sorry, it's just too complex, but at least you're giving the good things to remember. Self collision crashes the sim, the terrains issues, the meshes, the how to set up the robot, like the height, the starting positions, the things.
Mm-hmm.
The joint names has to match. The joints has to be also, they have a schema, and the schema needs to match, otherwise it does not move anything. The Hydra is important because that's how you set up your PPO and everything else. The scripts is where you're gonna get you're gonna call the task, and the task has the gym. I don't know where the PPO itself is. What is the other things? The robot environment, the terrain doesn't work. How you task will choose to put your task will choose there on the dictionary. Okay, so let me go here. We create
What kind of graphics card do you have?
a Titan.
Oh, cool.
So cool, like the NVIDIA
Those are the
gave it to me.
server.
Is the Titan RTX is
Those are server grade ones, right?
is more is production grades, not server. The server grades don't have fan.
Oh, really?
Yeah, you don't wanna. Those are cool, but you need loud fans. Here. Let's pick a robot that works, right? Like where's Spot? I love Spot. Do you have a Spot in your lab?
Yeah, he is behind my fellow lab mates who are playing Super Smash.
All right, here you see Spot. Just Spot right now is the only one that I know that works. It trains like a charm, and you can actually control it. It's awesome. You should start with this then, like easier. You see how the joint is set, and then you go here, physics joint is attaching to the body, to the hip, which is this mesh here. It's just two meshes, and you see there's this red stuff.
Mm-hmm. That's like the range of motion or something.
Yeah, so when it goes, boom, you see it can only move so much up and down. See, it can clip through, but can only move so much. Is the range of motion. So you have to be very careful with this, otherwise you won't transfer to the real one. You can see the position of the joint.
So this will limit it from self-collision to some extent, right? Because
Yes,
it can still like hit itself, I assume.
but this doesn't have a drive. But when you add a drive, what is happening? I'm gonna add one that has a drive. I think it's from this Unitree, the B1. I think I left the drive on this one. Oh, so many things to do. You have no idea what you're trying to do to this. You're gonna hate your life in a few days.
Oh man. Yeah, it wasn't so bad working on the preview version of Isaac Gym.
You see this drive here that set damping and stiffness?
Wow.
Because the velocity controller, it has damping and zero stiffness. The
Mm-hmm.
damping represents the compliance of your motor, of your robot controller. You see how it's rigid?
Mm-hmm.
This is the damping action, and it's keeping the position by literally telling it go up, down, up, down, up, down real fast. Like a spring. It's literally vibrating real fast and it's slowly going down. It's actually moving very slowly. So these things that drive. The drive, the code on Spot on the robot's articulation stuff, it overrides a drive, and here has a damping thing. See, a damping. Yeah, it's a damping. Not from here. Wait, I don't know exactly where it is, but we will override this drive and create its own drive using the things you have in the YAML and on the code itself.
Mm-hmm.
You create a new one that has a maximum force it can do. This is important because these parts have mass, therefore have inertia, a momentum, and then you need a force. Also, otherwise you will try to move but won't move. You're just gonna just hit the ground and don't do nothing. And then has this target position velocities and stuff. Like in this case, it's to 0, so it's not going to move. But like you're gonna override stuff, and this is what's gonna make move, and that's what you have to configure in the Python, and this has to match the real robot. Otherwise, when you transfer the RL, will think your actuator can do something it can't. That's why you have to set up all this. The transform. You see, this is the. I think this is this. Why this angle here? So you have to tweak this too. So this is a lot of finesse. The Go one. Let me delete these robots and get the Go one. I have the Go one already. Mostly done.
Isn't Unitree, or there is like a UFC file for the Go one that is inside of Isaac Sim
It
somewhere?
does not work.
Oh,
To make that work, you have to do way more work. It's here. I'm gonna show you why it doesn't work. Actually, they're exactly the same thing on I start with, but I had to change a bunch of stuff. I'm in life.
oh, there's a Unitree one.
Oops. Yeah. All right. So saw how here on the joint itself I have physics joint and stuff, and I removed the drive and I put. No, I didn't remove the drive in this one, but it has a drive here. But they both behave different. See, this does this, that one just falls, right? So why the one does that? As you can see, this has this file format, and this the other one has this, right?
Could you turn on the colliders for them so we can see what's happening?
Oh yeah,
This
like
one doesn't have the views you were saying that limit the colliders, so we should be able to see those.
No, this is not using the views. This is not using anything on the Python yet. I'm not running OIG. So this has different names for everything. See, this has the trunk where
Okay.
you have the joints, and the joints they have a different configuration for the drive. And if I actually go on this one and change, you're gonna work just like this one. But for this to work, the file, the name of the print, the name of the joint has to match the schema I have here. Oh gosh, where? See here, like is configure joint properties. See joint path. You're gonna be looking for these terms, heap, tie, HAA on the base. See, you're gonna be looking for this stuff, and you see how this is. Base is not base. Base is just this floating base that has some configurations, and trunk is just some random crap. Like no, it's not. It's the base that has the joints. So these won't find the things here. So yes, you can use these, but then you have to rewrite the entire code to work with this. So I thought easier to just rename the things in the robot than rewrite thousands of lines of Python.
Right. And so it probably something in the way we've converted the Go one over probably is how it's not registering, or like something's colliding or forgotten to change, maybe. I don't know.
Yeah, and then you also have to delete a bunch of stuff on this one, or add stuff. You have to modify. This is straight from the URDF. What they did here, they use this thing here, workflow URDF importer. They click here. They use this thing here and then import it from the URDF Unitree offers to this, and then put here. That's the only thing they did. They did not do anything. Like okay, that's all they did. So if when you import the URDF to USD, you have to configure a bunch of stuff that works with the RL thing. So just importing does not does not work. You still have to tweak the joints, the drives, the masses, the fixed joints, because sometimes the fixed joints they glitch on when you run the Python script. Sometimes a fixed joint makes you fix in place, and then you just move the legs, but the robot doesn't fall.
Right.
So you have to is a process of back and forth where you go a lot, run, fails, go back, try to figure out why, and then that's why I'm creating a schema and possibly an extension. So my idea, you know how mocap works on this character creator. This is how they do video game, right? And they open the thing and has like a virtual thing, like a character, and then has lots of dots, like on the face, has lots of dots on the faces, on the bodies, on the hands, and the fingers. So my idea was to make it there here, like an extension that says, because all these robots has similar, design, 12 degrees of freedom, they have just same types of joints. I was thinking to make like that, and then like it goes over. You go over on the UI already matching the things, and then it generates this code here on its own.
No, that would be awesome.
So instead of having to have a schema here hard coded and then make the robot match this, or make this match the robot, we just pick the prim on the name of the stuff here on the UI, and then it loads on here on the code. That's
awesome.
yeah. So that's like a long-term plan. So far, I have to figure out how to first make it work, right? Like at least like figure out why it doesn't work and how make it work, and this code I need to dive deeper and actually make the terrains and make it train, and then I think I make it things like that allow you to do that. Then people could design their own robot, import the joints, and then make it just go into this code.